In this video, we're going to be learning about the concept of iterators in more detail. But before we learn about iterators, let's just recap on what an iterable is. Now, anything that you can loop over is described as an iterable. For example, a list is an iterable. We know that if I create a variable called my_list and set this equal to a list of integers 1, 2, 3, and 4, if I put for I in my_list and then print I, we print 1, 2, 3, and 4 to the screen, one at a time. In other words, our for loop is iterating over this list, and it's because my_list is an iterable. Now, for an object to be considered an iterable, it must have the dunder, iter, dunder method associated with it. And to check to see if an object has this method, we can use the dir function, which we've seen in the course previously, and this returns all of the attributes and methods of a particular object. So if I now pass in my_list to the built-in dir method, you can see in amongst all of these methods, we have the dunder, iter, dunder method included. And this means we're able to iterate over this object in a loop. So let's start from the beginning to really understand how a for loop works. Now, to create an iterator object, we can call upon the dunder, iter, dunder method. So if I put the list my_list, then use dot notation and put dunder, iter, dunder with a set of parentheses, i.e. we call this method on this object, you can see that when I run this code cell, we return a list iterator object which is stored at this location in memory. So now we have this iterator object, let's see how we can iterate through them to obtain the values from the object. First, I'm going to assign this iterator object to a variable called value. Now we know that this iterator object is now an object in which its elements can be iterated over one at a time. And for an object to be an iterator, it actually needs to have two methods associated with it. We've just seen the dunder, iter, dunder method, but it also requires a method known as next. And these two methods collectively are known as the iterator protocol, as they are both required to produce an iterable. So what does the next method do? Well, let's once again use our my_list variable. Here, the value variable is an iterator object, and we can get each element of the iterator by using the next method. And the next method returns the next element in the iteration. So if we create a variable called element1 and set this equal to value, which is that iterator object, then place a dot, then access dunder, next, dunder with parentheses, so that next method, and then print out element1, you can see that we get 1 printed to the screen. So we've accessed that first element from the iterator object. If I now create a variable called element2 and copy and paste the code above, you can see that we then get back the second element in the list, which is 2, and unsurprisingly, if I copy and paste this twice more and change the variable names to element3 and element4, we get 3 and 4 returned accordingly. So we're able to get each element in the list by first creating an iterable and then using the next method to get each element in that iterator object. Now you may be thinking, why are we calling them methods like this? Well, this is a way that we call methods, i.e. by using dot notation and accessing the method names respectively. But Python does have built-in functions that make calling these two methods easier. So we can actually refactor our code, i.e. clean it up, as follows. We can change the dunder, iter, dunder code line to simply be the built-in iter function, and then pass the object name into parentheses. In this case, my_list, and for the next methods, we can simply use the built-in next method and pass the value variable into parentheses. And when I run this code, we get the exact same result. Now at this point, we have got to the end of our list. We've actually accessed the fourth element in the list. So what would happen if I called the next method one more time? Well, let's find out. So element 5 equals next brackets value. If I now print out element 5, you can see that when I try to run this code, we run into a stop iteration error. And this is because we do not have any more elements to iterate over in this specific iterator object. So keep this in mind for the time being. Now I have an interesting fact for you which may come as a surprise. For loops, which we've seen previously, behind the scenes actually use infinite while loops with some additional logic applied. So this may sound very confusing. A for loop is actually a while loop. Well, let me show you how for loops actually work behind the scenes. So we'll create a new list called new_list, and we'll set this as even integers 2, 4, 6, and 8. I'm now going to create a list iterator object on this list. So I'll create a new variable called iter_new_list, and I'll set this equal to the built-in iter function, and we'll pass in new_list. So we've now created an iterator object. I'm now going to create an infinite while loop. So if I put while true, we know that this will just continue running until we break out of the while loop. So while true, we are first of all going to try the following code block. So we can put element equals, and then we can call upon the built-in next function and pass in the iterator object, which is that iter_new_list variable. We can then try to print the element. Now we know as soon as we get to the end of new_list, i.e. the value 8, there are no more elements, and this will raise a stop iteration error. So we can then have an except block which says except stop iteration, then we simply want to break out of this while loop. So let's just recap one more time. We have a list object that we've created at the top, and we've then created a list iterator by using the built-in iter function. We've then created an infinite while loop, and we're first of all going to try to access every element by using the next method on this iterator object. Once we get to the end of the list iterator and we run into that stop iteration error, we simply want to break out of the loop. So when I run this code, you can see that we print 2, 4, 6, and 8 one at a time. And this is essentially what a for loop would do. So once again, if I put for I in new_list and then print I, we print the exact same result to the screen. So why am I showing you this? Well, when you utilize for loops are actually creating an iterator object behind the scenes. They then implement this while loop and they break out of the while loop upon a stop iteration error. So iterables are created with those two methods, iter and next, in place. Which now leads us on to thinking, well, how can we build out our own iterators? Well, let's run through a quick example. Let's say we wanted an iterator that once called, it will produce the 10 times table up to a certain value of choice stipulated by the user. So we'll first of all create a class called times10, and we're first of all going to include the init method, so we can put def dunder init dunder, and we'll pass in self, and a second parameter called max, which will default to 0 to start with. We're then going to define an attribute called n, so we can put self.n equals 1, and then we can put self.max and define a max attribute and set this equal to max, which is passed in when creating an instance of this class. Now I've mentioned that an iterable has to have the iter method defined, so we're going to define that now. We're going to put def dunder iter dunder and then pass in self, and then we simply want to return the object itself. And this will enable us to utilize the iter method to create an iterator object. We also know we have to define the next method, so we're going to put def dunder next, dunder, and pass in self, and then we want to stipulate the logic that should be applied on each element for our own custom iterator. So we'll first of all put some logic that states if self.n, and this first of all starts at 1, is less than or equal to self.max. So if a user puts in 5 when creating an instance of this class, then we're only going to get the first 5 multiplications of 10, where we can then create a variable called result and set this equal to self.n times 10. So to start with, self.n is 1, so result will store 1 times 10, which is obviously 10, and we want to return the result. Now upon the next iteration, we want to increase n by 1 so that we get 2 times 10. So just before the return result code line, we also want to increment self.n plus equals 1. As soon as self.n exceeds self.max, then this if statement will evaluate to false, at which point we want to raise a stop iteration. There are no more values that we want to see from this iterator object. So we can put else, colon, and then we will raise a stop iteration exception. So let's now see our custom iterator in action. We'll first of all create an instance of the times 10 class, so we'll create an object called numbers and set this equal to times 10, and for the purposes of this example we'll simply put in 3 as the max variable. We now know that with this numbers object we can create an iterator object because we've included the iter method inside of this class. So if I create a variable called I and set this equal to a call on the built-in iter function and then pass in the variable numbers, we can now get the values from this iterable by using the built-in next function. So if I were to print and then call upon next and pass in I and then do this twice more, you can see that we print to the screen 10, 20, 30. Exactly what we wanted our iterator object to do based on the logic we included in our class. Now what do you think will happen if I try to call upon the next function and pass in I once again? Well, let's see. If I put print next and then pass in I, we run into that stop iteration error. And that's because self.n at this point would be 4, but we only passed in 3 when we created an instance of the class. And because self.n is now greater than self.max, we've raised that stop iteration error. So lots to consider here, and you may be thinking, why are you showing me this, Dean? Well, the advantage of using iterators is that they can end up saving so much resource on your machine. So for example, if you were to try to store every single even number that exists, well, this is obviously an infinite list, but your machine only has a finite amount of memory, so it wouldn't be able to store all of these values. But creating an iterator object that stores this infinite amount of numbers would theoretically enable you to store an infinite amount of items in a finite amount of memory. Because they're not physically stored, an iterator object is created and then you can iterate over them one by one. Now there's an easier way to create iterators in Python, and I'm sure you've guessed what it is. It's the use of generators. And we're going to learn all about generators in the next video. So I'll see you there.